Today we will discuss about the sorting problems on arrays. So what all sorting problems we will be learning during our training process is one is a bubble sort and optimized bubble sort. Okay, we will see all the applications, advantages, disadvantages of all the sorting techniques, what are the time complexities, right, how we can make them better. All those scenarios we will analyze it here. Okay, now, now what we're gonna do is, right, we'll make a list of sorting techniques what we will be learning. Insertion sort, sorry, let's have selection sort first. Selection sort and stable selection sort. Okay, next. Okay, and insertion sort, which is a stable one. Then we will have a quick sort. Okay, quick sort. Then we will have merge sort and we will have a bucket sort. So these are the sorting techniques that we will be learning it. And if time permits, we will go with heap sort also, right? So this is the scenario as of now. Okay, now, right, let us start with the first one today, right? That is bubble sort, one of the simplest sorting technique. Okay, one of the simplest, right, we can say that it's a most simplest sorting technique. Okay, now the question comes is, right, first of all there are few things that we need to understand regarding bubble sort here. Okay, so what are those? First you need to understand the time complexity, right? See, the time complexity of bubble sort is O of big O of n square. This is n square. Okay, or else I'll write it as n into n. You can take it as n square. Better, let's write it as n square. Okay, that is not XOR operator. Okay, and we need a auxiliary space. Auxiliary space of big of 1. One temporary variable is required here for swapping purpose. That is called as only one extra variable is required. That is called as a extra space or auxiliary space. Now let's look at advantages of bubble sort. See, it is easy to understand and implement. It is easy to understand and implement also. Okay, now next thing is, it doesn't require, right, any additional memory space. Means what I'm trying to convey here is, we don't need too much of memory. Just to for swapping purpose we just need one variable, that's it, nothing more than that. Okay, now the next thing is, it is, right, it is a stable sorting algorithm. It's a stable sorting algorithm. So means that, right, basically why do we refer it to stable and unstable? These terms will come into picture when you are sorting the arrays. When you have duplicate elements, when you have duplicate elements, right, okay, they will maintain their order of appearance, guys, 1 second. Now the bubble sort is also a stable sorting algorithm. Why? Because whenever you have an element with the same value, right, they will maintain their order itself, right? Okay, they will maintain their order, so they don't change. I will give you an example for this one, right, during the explanation. Okay, these are the basic advantages of bubble sort. Let's look at disadvantages. Okay, let's look at disadvantages. Okay, let's start with the first one. See, main issue is time complexity is is high. That is big O of n square, right? So which makes, right, sorting very slow for large data sets, right? So in this way you need to understand that bubble sort must be used for only smaller data sets, right? It must be used for smaller data sets. Okay, and second one is bubble sort has no real world application. We never use it anywhere, right? Probably used in education sector to teach students about sorting, because this one takes a lot of time in sorting when you have a large amount of data. So this is the reason we never use it in real world application, but yet we need to learn it because the companies will ask us, right? They will ask us like to check the logical abilities of ours, to check the logical abilities of the candidates. Okay, so let's start understanding bubble sort. Okay, so first of all, let's start with bubble sort. Now, okay, in bubble sort, what we will do here is, let us take an array element. Okay, array with some elements. One second. Okay, let's take an array with, okay, some element. Okay, let's start with that. God, some problem started. Okay, so here is an array with some 5 elements. Let us take the 5 elements as 10, 8, 6, 3, 1. These are the array elements that I have here. Okay, these are the array elements I have. Now I want to do the sorting in ascending order. I want to do the sorting in ascending order. Okay, so how we can do that? Okay, how we can do that? Let's observe. Bubble means what? Whenever two bubbles, right, come in contact, whenever two bubbles come in contact, they would burst, right? They would burst. So what we will do here is, in this logic or in this algorithm, the comparison always happens with the adjacent elements. Comparison always happens with the adjacent elements. Now you will compare the first element with the second element. If the first element is greater than second one, then the swap is required. So if you swap these things, okay, now if you swap these things, right, what will happen here, right? These values will get interchanged. 8 and 10, 8 and 10 will get interchanged. Now after this operation, next what we will do is, we will compare 10 with 6. Now again we will use the same condition. The first element is greater than second element, then again we will swap. Again we will swap. Okay. Now what will happen after swapping? The values will interchange, right? Values will interchange, right? Okay. Let's observe here what all changes will happen. 10 will go to the next place, right? 10 will go here and the 6 will come down here. Now in this one you will do, right, comparison of 10 and 3. Same condition. If it is true, swap them, right? So after swapping, what happens here? After swapping, what happens? Okay, these values will get interchanged. So 10 will move to the next place and 3 will come down here. Okay, now what you will do? You will compare the last two elements, right? Same condition you will check. If the first element is greater than second element, then you will swap them. Okay, now after swapping, what happens here? After swapping, what will happen with these values? Just observe the final result. Just observe the final result. What happens here after swapping? Okay, now one second. Okay, these values will get swapped, and here you will have 1 and this will be 10. Now after swapping this one entire process, can you see that the biggest element has come and sat in the end? One element is already sorted. One element is already sorted. Now this one entire thing is called as first pass, right? One entire thing is called as, this entire process what you have done is called as first pass. It is called as first pass. Now what we will do is we will repeat the entire process for the remaining elements, right? One element is already sorted, right? One element is already sorted. Now we will repeat this step. We will repeat this step for the remaining elements. Now we will again start comparing from the first element and second element. If it is greater, then we will swap. If it is greater, then we will swap it. So if you swap these two values, now, right, what will be the changes in the values? Just observe here, right? So 6 and 8 will get swapped. 6 and 8 will get swapped. 6 will come here, 8 will come down here. Now you will compare 8 with 3. Now you will compare 8 with 3. Now again you will check the same condition. First element is greater than second one, right? Then you need to swap them, right? Now after swapping, what happens here? After swapping, what happens? Right? These values will get interchanged, right? Okay. So 8 and 3 will be interchanged. 3 will come here, 8 will come down here. Now you will compare 8 with 1. If the condition is true, again you will swap them. So if you swap, what will happen here? Right? After swapping, just after swapping, observe what will happen. Another element gets sorted in the end. Another element will be sorted at the end. So after swapping, 8 and 1 get interchanged. 1 will come here and 8 will come here. Now you can see that one more element is getting sorted. One more element is getting sorted. Now this entire process what we have done, right? This entire process what we have done is called as second pass. Is called as second pass. Okay. Now the next thing is, right, we will repeat this entire process for the remaining three elements, right? We will repeat the entire process for the remaining three elements. So let's do that. Okay, so we'll take that here. Okay, let's start with the, right, another pass. Now what we will do, these are the values, right? Right, these are the values what we have. Two elements are already sorted. Now you will start comparing the first two elements again. If the first element is greater than second one, swap them. If you swap, the 6 and 3 will interchange. 6 and 3 will interchange, right? 6 and 3 will interchange, right? Now you will compare 6 with 1. If it is true, swap them. If it is true, swap them. After swapping, the 6 and 1 will get interchanged, right? If these two elements gets interchanged, right? So, okay, this one will become 1 and this one will become 6. Now you observe here, one more element is getting sorted, right? So this one we will call it as third pass. This one we will call it as third pass. Now we are left with two more elements, right? We need to start, right? We need to start the same process again with the remaining elements. Now you need to compare this and this. If these two, the condition is true, right? If the condition is true, right, then swap them. After swapping, what will happen? The values will get interchanged. Which are the values that will get interchanged? 3 and 1, right? 3 and 1. So 3, 3 and 1 will get interchanged. Now after this, you can see that the entire array is already sorted. And this is called as fourth pass. This is called as fourth pass. This is called as fourth, right, pass. Are you clear about it? Now we need to understand certain facts here. Okay. So we need to understand certain facts here. Let's see what are those. Okay. If n elements are there, right, observe this, we had 5 elements. N is equal to 5 elements are there. Now how many number of passes are required to sort the entire array? How many number of, one second, okay, so if n is equal to 5, that is the number of elements, so the number of passes will be equal to n minus 1. Okay. Now you can observe in the first pass. In the first pass, you can observe 1, 2, 3, 4. Total 4 comparisons are happening. In the first pass, total, right? Total 4 comparisons are happening. Now in the second pass, you can observe 3 comparisons are happening. Now, if you go for the third pass, only 2 comparisons are happening. Now, in the fourth pass, you have only 1 comparison which is happening here. Now, what I'm trying to say here is, right, as the pass number is increasing, right, as the pass number is increasing, number of comparison, number of comparison is equal to n minus I minus 1. So in the first one you have n minus 1, but in the second one more thing will reduce. One more time it will reduce. In the third time it will become n minus 3. In the fourth time it becomes n minus 4. That way the number of comparisons are reducing. So what we need to do here is to write a program for this. Let us write a program for this one. So let's open some online compiler. Okay, some line compiler here. Now, okay. So here, first of all, we need to declare an array with some element, and we need the size of the array, right? And we need, right, printf enter size. Let's start reading them. Scanf double quote percentage d comma ampersand n. Once you got the number of elements, then we need to read the array elements. So enter elements, read the array elements. Now what I will do is, since we are aware about functions, I will use a function called as read array. It is a user defined function. It is, I am creating this function read array. Okay, I am creating this function read array. Okay, now what is the job of this function? It will read the array elements and store it into ARR. So now what I will do is, I'll pass the array as a parameter and the number of elements as a, right, second parameter. Okay, so next, so this will do the job of reading array elements. Now what I will do, I have the elements, I have the size of the array, I have the array elements also. Now what is the next job? Next job is, I will do print the array elements before sorting, right? I will print the array elements before sorting, so that it becomes easy for me to compare in the last. Now, so before sorting, let's print the array elements. Now printing array elements, I will create another function. The job of that function is to print array elements. So arr comma n. Okay, arr comma n. So two parameters we have passed. Next is, we have to sort, bubble sort. Now to sort, we need to send these two parameters, array and number of elements. Give these two parameters to the function, it will sort it and give us back. Next, what I have to do after sorting, I have to print the array elements again to check whether the elements are sorted or not. So let's call a print array function arr comma n. So we are trying to build a function for reading array elements, printing array elements, and bubble sort for sorting. Now we will start writing a function for all of these, right? Body or a function definition for all of these one by one. So the first one is, let's go with a read array. So void read array int arr comma int n. So how do we read array elements? We need to run a loop I is equal to 0, I less than n, I plus plus. This is called as traversing. Traverse the array and use scanf percentage d double quote comma ampersand arr of I. This will read the all the array elements which is given by the user. How many number of elements? That will be given by n variable. Okay. So next, which function we have to write? We have to write a function to print array elements. So this will also not return anything. Now we have int arr. First parameter is array. Second parameter is number of elements. Now declare a variable. Then for I is equal to 0, I less than n, I plus plus. This is traversing an array. So once you finish traversing, then what is the job we have to do? We have to print all array elements. Okay. Now arr of I, print all the array elements. Now comes is bubble sort. Now comes is bubble sort. Void bubble sort int array int n. So we are passing two parameters to the bubble sort function. First one is array, second one is a number of elements. Now see here, the logic what we have discussed here is, I need one loop to keep a track of number of passes. I need one loop to keep a track of how many passes are there, to count how many passes are there. Because those many passes I have to execute. Correct? Those many number of passes I have to execute. Right? Now, and next thing I need is number of comparison in number of comparison in each pass, right? I need one loop to keep a track of how many comparisons in the first one, how many comparison in the second one, how many comparison in the third, and how many comparisons in the fourth. Now this I will indicate, this I will indicate, right, which pass number. It will indicate pass number. If I is equal to 0, first pass, right? If I is equal to 1, second pass, I is equal to 2, third pass, and so on, right? So let's start writing a sorting technique here. So we need two loops. So for that we need I and j variables. So first we need to keep a track of number of passes. Number of passes is represented by n minus 1, right? So the first for loop what we are writing, it is keeping a track of number of passes. Okay. Now inside this, when the first pass starts, when the first pass starts, right, we need to do the comparison. How many comparisons we should do? We should do n minus I minus 1 comparisons. So this J for loop is keeping a track of number of comparison in each pass. In each pass. Now inside this you compare. Now J variable is used for keeping a track of number of comparison. Now if I want to compare the first element and second element, now don't you think I need to use the j variable only? Because j variable is related to comparison. J variable is related to comparison. So if ARR of j is the first element, because j is starting from 0. Now the first element needs to be compared with what? The first element needs to be compared with what? Second element, because we need to compare the adjacent elements. We need to compare adjacent elements. So if ARR of j first element is greater than ARR of j plus 1 second element. If it is true, call a function called as swap, pass the address of both the variables, right? Pass the address of both the variables so that the swapping will happen in the original memory of arrays. So that the swapping will happen in the original memories of array. So we need to write the swap function now. We need to write the swap function. So void swap of, since we are passing a address here, right, we need a pointers here to receive them. Okay, we need a pointers to receive them, right? Now int temp, declare a temporary variable, store star p inside that. Now star p is equal to star q, store the star q value into star p, then star q is equal to temp. So this is how you will swap the values, right? Now let us execute it and check. Let us execute it and check, right? Let's give 5 elements. Let's give 5 elements: 50, 40, 30, 20, 10. So before sorting and after sorting. Please do remember that in the bubble sort, right? In the bubble sort, right? Outer for loop is taking care of number of passes. Okay. Inner for loop is taking care of number of comparison in each pass. Number of comparison in each pass. That's it. Bubble sort. Are you clear on? Okay. There's a catch. We need to understand about bubble sort. Okay. Now see here. One second. Okay. Now you see here. Let's take an array. Okay. And pick up five elements. Let's pick up five elements: 50, 10, 20, 30, 40. Now, what I want to do a sorting in ascending order. Okay, I want to do sorting in ascending order. So now observe these datas, right? After first pass, right? After first pass, what are the array values? Let's observe that, right? Let's observe that. What are the array values after the first pass? 10, 20, 30, 40, 50. Now, don't you think after the first pass, the array is already sorted, right? Array is already sorted. Now, in the second pass, third pass, fourth pass, right? These passes are not needed, correct? Because the array is already sorted after the first pass, correct? But the logic what we have written, this will execute second pass, third pass and fourth pass also, which is a waste of time, isn't it? Which is a waste of time, correct? So, w- so we need to come up with a strategy, right? Wherein, right, we can control this unnecessary execution. Now, in the first pass, swapping has happened, so it is all working fine. But whereas in the second pass, just observe in the second pass, this is the array you have. Now, do you think the swap operation will ever work in the second pass? Do you think that the swap operation will it work in the second pass? Definitely it won't work because all the array elements are already sorted. Correct. So what we have to do is for one entire pass, swap is not occurring, then can we say array is sorted? If swap is not occurring in one entire pass, can we say that array is already sorted? Correct. So this is what we need to keep a track. This is what we need to keep a track, right? So how do we do that, right? Now what I will do is I'll take this bubble sort code and I'll create another function. I will make it as optimized bubble sort. Okay, I'll make it as optimized bubble sort. Now here what we will do is we will take one extra variable swapped and initialize it to 0 before we start. Make it 0 before comparison in each pass starts, or before the start of the pass, right? Make it 0. Now whenever the swap operation is occurring, whenever the swap operation is occurring, change the value of that variable swapped is equal to 1, right? So what are we doing is this j for loop is taking care of number of comparisons and also swapping the elements. Now before I start comparison, I will take one variable and keep it 0. If the swap is occurring, then it's the variable value will become 1, right? So if it is not occurring, variable value will always remain 0. Now what we will do here is Okay. Once the J for loop execution completes and the control comes to this line, when the control comes to this line, it indicates all comparisons in the current pass are finished. You finished a comparison in the one entire pass. Now what I will do, I will check whether swap of values is it happening or not. If swap is not occurred, if swapped variable is still 0, then obviously swap has not occurred for one entire pass. So break and come out. No need of continuing with the next pass. If in one entire pass, we are doing comparison. So once this comparison is finished, check did any of the values are they getting swapped. If they are not swapped, then break and come out. Why? Because the array is already sorted. Array is already sorted. Right? Now this is called as optimized bubble sort. This is called as optimized bubble sort, which will not execute in this example, which will not execute, right? Third and fourth pass will not be executed. That is the time we can save inside that. Are you clear on the entire process of bubble sort?